Alright, we're going to be talking about the product rule and the quotient rule. So let's get started with the product rule. Okay, so far we've differentiated functions that look something like this, where we have f of x equals u of x plus v of x, where these are both functions of x, and we know that we can differentiate these by just taking the derivative of each of these and adding them together separately. Oops, that should be a prime there. Okay, and here would be an example. X cubed plus x to the minus 4/3 minus 2x to the minus 1/2. We know how to differentiate this, right? And we can most of the time get a function to look like this, and then we can differentiate them. Okay, so that's the type of problem that we've seen so far. But what if we have two functions that are being multiplied together? Okay, where we have x plus 2 times 3x squared minus 4 to the power of 3 over 2. If I have a situation like this, well, now this becomes a little bit harder to get into this form. Okay, maybe it's possible, maybe it's not, but it's going to take a lot of work. Okay, so we're going to use a new rule today, and it's called the product rule, because we have the product of two functions, right? This is a product of two functions. So we're going to use the product rule. All right, and here it is. This is the product rule. If f of x is the product of two functions of x, now these both have to be functions of x, u of x and v of x, then the the derivative of that entire function is the product of the first function times the original second function plus the product of the second function times the original of the first function. Okay? Here's another way to look at it, a little bit simpler, a simpler form without all of these x's in them. If u and v are both functions of x, okay, so both of these have to be functions of x, then y prime, if y is uv, then y prime is u prime v plus v prime u. And the order doesn't really matter here. So if you look on the internet or in another textbook, you might see these switched around, but it's all the same thing, okay? I take one function, derive it, multiply it by the other function, add that to the original of the first one times the derivative of the second one, okay? So let's try an example here. What is the derivative if y equals this function here? Notice that I have two functions. I have this function and I have this function. This actually would be a chain rule type of question because I have a function inside a function, but that's okay. I'm going to split it up into two blocks. Okay, this is going to be my u and this is going to be my v. So I define it like that. I'm going to write u so it's easier to differentiate. I take the derivative of u, okay, and that becomes 1/2 times x to the 1/2 minus 1, which is negative 1/2. And v is, since v is this function, when I derive it, I end up with 3 times 2x plus 1 raised to the power of 3 minus 1, which is 2, times the derivative of the inside. So notice here I've used the chain rule. Okay? Alright, so now that I have u prime and v prime, well, now I can just use my formula, y equals u v prime plus v u prime. Okay, notice I'm changing the form a little bit, okay, but it's the same thing. All right, I just take the derivative of one and multiply it to the original of the other. So let's just I've written it in this way. Let's write that in. So I have u prime. I substitute now v. I just substitute v prime. I substitute this whole thing in. And for u, I substitute my original u function in. Very straightforward, very easy. So once I get this, I simplify, and I get 1/2 x to the minus 1/2. Okay, so that just stays the same. I've simplified just a little bit here with this 2 and the 3, and then I've moved the front, this little function out to the front. Okay, so that would be the derivative of this function. Notice that it's pretty messy, okay, but we're just practicing our differentiation skills here. So you might get some random ones like this. Now it's important that you know your exponent rules and you are very apt with your algebra, okay, or else it becomes tricky to do these differentiation problems. All right, let's try this. Y equals x squared times x squared minus 2x raised to the 4th power. Again, it's the same thing, same situation, right? Here's my u. I recognize that it's really two functions being multiplied together, so I'm going to use the product rule. There's my u. Whoops. Okay, there's my u. There's my v. I take the derivative of each of these separately, and then I plug them into my formula. So u is x squared, u prime is 2x, v is that function. I take the derivative of that, so that's going to be 4 times the original raised to the 3rd power times the derivative of the inside, which is 2x minus 1. 2x minus, whoops, that should be 2, sorry. 2x minus a 2. Okay, and then I plug those back into my formula. U prime is 2x, so I put that in. V is that. V prime, so be very careful with your parentheses. Make sure you're staying very organized and neat, and try to logically explain all of your steps so that it's clear both for you and for me what you're doing. So I put my v prime in, and then I put my u in, okay, and I get x squared, and then I just simplify. You don't need to simplify everything, okay? With a lot of these questions, all I want to see is that you know how to differentiate them. But as far as constants, you should be able to simplify constants, okay, combining numbers, and maybe if it's obvious that there's an easy simplification, you should do that as well. For instance, I move this to the front just to be a little bit neater, okay? So that's the product rule, very straightforward. I think later on you'll be able to do these types of problems without writing all of this down. But for now, when you're beginning, go slowly, make sure you're building that foundation, and then later on you'll just be able to recognize it and start differentiating right into this line right away. Okay? All right. The quotient rule. So we know how to do products now. We know how to do two functions being multiplied together. We know how to do the addition rule, where two functions are being added or subtracted together, or subtracted from each other. And now we're going to talk about a situation when we have two functions and one is being divided by another. Okay? So we've actually seen this kind of question before, right? We know how to derive this. Well, we could write this as 3x over x plus 6 over x, and then I could write it as 3 plus 6x to the minus 1, right? And then I could derive that. But sometimes it's not, the denominator is not going to be this neat. And so you'll end up with functions on the bottom that are pretty complicated, and it's hard to simplify this, my quotient, into a form where I can use just the power rule and the addition and subtraction rules. Okay, so we're going to use a new rule, and that's called the quotient rule. And here it is. If y equals u over v, all right, so I have u on the top and v on the bottom, then the derivative is actually going to be the bottom function times the derivative of the top, okay, minus the top function times the derivative of the bottom, all over the original v squared, the original bottom function squared. Okay? I like to remember it like this. Your book might have it in a slightly different form where these two are switched. But the order does matter here between these two terms because there's a minus. So please don't write u v prime here or v prime u here. Okay, it's got to be u prime v in front or v u prime, depending on how you want to write this. Okay, I like to remember it as v. I always just start with a v and a v. Okay, I know the bottom's going to be squared, so I just write v, v, and then I do the opposite, u prime, and then this is the opposite of this. Okay? Alright, so let's do a couple examples here. Find dy dx for the following functions. Okay, y equals 1 plus 3x over x squared plus 1. Okay, so u is going to be the top, which is 1 plus 3x. V is going to be the bottom, which is x squared plus 1. U prime is then equal to 3. V prime is equal to 2x. Okay, so this one doesn't look so bad or messy. All right, let's simplify this. If I use my formula, dy dx must be equal to, okay, vu prime minus uv prime all over v squared, right? Okay, so what is my v here? My v is x squared plus 1, so I just substitute that in. Okay, x squared plus 1 times my u prime, which is 3, minus my u, which is 1 plus 3x, times v prime, which is 2x. And all of that is over v squared, which is x squared plus 1 squared. All right, not very difficult once I isolate the two functions, okay, whether it's what my u is and what my v is. And now it's just a matter of simplifying the top or the bottom. In this case, the top looks fairly simple, like I could simplify this and combine everything, so let's just go ahead and do that. So that becomes 3x squared plus 3, and that becomes minus 2x. I'm going to distribute the 2x through, and that becomes 6x squared, okay, all over x squared plus 1, quantity squared. And so that simplifies even further. 3x squared minus 6x squared, that's going to be a minus 3x squared. Okay, plus 3, that's the only constant term, so I'll put that at the end. And then I have a minus 2x here. So that would be my answer. Okay, we're going to end up with x squared plus 1 quantity squared. Okay, so this is my derivative for this, given this function. Okay, let's try this one. What's the derivative of this? Again, same deal. U is equal to root x. So u prime would be equal to, since that's x to the 1/2, that would be 1/2 x to the minus 1/2, right? Because that would be 1/2 minus 1. V would be 1 minus 2x quantity squared. And so v prime would be, now notice this is a chain rule problem, so this would be 2 times 1 minus 2x to the 1 times minus 2, the derivative of the inside. Okay? And from here, now I'm just going to substitute right into this formula. And let's just go ahead and do that. That's v would be 1 minus 2x squared times my u prime, so that would be times 1/2 x to the minus 1/2, minus u, which is x to the 1/2, times v, right, which is minus 4 times 1 minus 2x. And all of that would be over v squared, which would be 1 minus 2x squared. Okay? And then I could simplify this a little bit more. Okay? It doesn't look like this is going to be very easy to simplify. Okay, I could still do it, but let's just simplify the constants for now, and I would accept that. Okay, because I don't want you to. I want you to understand the concept here of differentiation. So this would become 1 minus 2x squared times. Okay, I guess I could put the 1/2 out in front. Okay, 1/2. And this would be x to the minus 1/2 plus 4. I bring that 4 out, x to the 1/2 times 1 minus 2x all over 1 minus 2x quantity squared. Okay, so that would be it. Okay, if you left your answer like this, oops, sorry, that would be 1 minus 2x squared, wouldn't it? Okay, so that would actually be to the 4. Okay, and I guess you could factor this out. Okay, if you really wanted to keep simplifying, you could factor. I see that the term 1 minus 2x is available there, so let's just go ahead and do that. Okay, if you wanted, you could go 1 minus 2x times x to the minus 1/2 plus 4 x to the 1/2 all over 1 minus 2x, and that would be to the 3rd power, because that would be a 3, and that would cancel out, and that would cancel out to a 1. Okay, so if you can simplify up to here, I would accept that. All right.